Alright, in previous videos I introduced steroids to you as one example of the chemical messages that our body parts use to communicate with each other. And we call those chemical messages hormones, but I haven't really gotten to tell you all about steroids and where they come from and how they're made, and that's what I want to do today. And so to accomplish that, I really need to start by introducing you to terpenes. And terpene might not be the most familiar of words, but it refers to a class of lipid molecules that are made of a repeating distinct set of carbon atoms called isoprene. And so I'll draw on that carbon unit called isoprene. And isoprene has this really distinct structure of 4 carbons chained together. So 1, 2, 3, 4, with the 5th carbon branching off of one of the middle carbons. And this 5-carbon unit repeats to build larger and larger molecules. And so as 2 5-carbon isoprenes come together, you get a molecule that has 10 carbons, and we call that a monoterpene. And one of my favorite monoterpenes right now is menthol, which looks like this. And this little guy is super helpful to me right now because I've had a pretty rough cough for the past week, and my cough drops are filled with menthol. And then if you add one more isoprene, you'd have 15 carbons. And that would give you 3 units of isoprene, and we'd call it a sequiterpene. And one example of a sequiterpene is ginger, and ginger looks like this. But you can see that ginger is made up of 3 isoprene units, and it fills up ginger snap cookies, and those are my favorite types of cookies. And so really you can just keep adding these isoprene units and making larger and larger molecules. And so I'll just go ahead and make a chart here. And remember, monoterpenes had 2 isoprene units, and sequiterpenes had 3 isoprene units. And if you added another isoprene unit to that, you'd have a diterpene. And it would have 4 isoprene units making 20 carbons. And it's called a diterpene now because it's really just 2 monoterpenes put together. And then you could add another one, and that would give us 5 isoprenes for 25 carbons, and that would be a sesterterpene. And you could just keep going, and you could have 6 isoprene units for 30 total carbons, and that would be a triterpene because essentially now we've got 3 monoterpenes. And then if you added another monoterpene to that, you'd have a tetraterpene, and that would have 40 carbons and 8 isoprene units. But really this could keep going, and we could keep adding isoprene units, and we'd find lots of nice plant oils that we'd make and vitamins, but that unfortunately is not our goal today. We're still talking about steroids. So I'm going to shift to how our body uses these isoprene building blocks to create the chemicals that it needs, and that's a process that's called biosynthesis. So let me clear some room so that we can talk about biosynthesis. And in biosynthesis, our body starts off with isoprene bound to something called pyrophosphate, which looks something like this. And I'm going to use the letter R to represent that isoprene unit for now, just so I can really show you what pyrophosphate looks like. And so that's pyrophosphate. This green area is pyrophosphate. And you probably won't be expected to know too much about pyrophosphate, but what you should know is that it's a really weak base, which makes it a good leaving group in organic chemistry. And that's the important part, because for the reaction that our body uses to build with these blocks of isoprene, it needs a good leaving group, and that's pyrophosphate. And our body really begins with 2 different isoprene pyrophosphates, and they're found in nearly all living organisms, and those are dimethyl allyl pyrophosphate and isopentyl pyrophosphate. And I've just shortened the pyrophosphate to OPP because that's what most textbooks abbreviate it as, and it saves quite a bit of time. But I will go ahead and write out the names of these just so I don't confuse you too badly. And those names make pretty good sense if you've practiced naming carbon molecules in, say, an organic chemistry class or something. But they probably sound like a foreign language if you haven't. So let's not get too hung up on them here because they don't help us much with the concept anyway. But what happens is the electrons of one pi bond act like a nucleophile and they attack this carbon, allowing the pyrophosphate to leave, and that results in a 10-carbon molecule called geranyl pyrophosphate. And so that's geranyl pyrophosphate. And then that process might happen again, leading to a 15-carbon farnesyl pyrophosphate. And forgive me if I'm butchering that pronunciation, but I'll draw it in. And that's farnesyl pyrophosphate. And then as these chemical reactions continue, our body eventually produces a triterpene, or if you remember, that's a 30-carbon molecule made of 6 isoprene units, and that triterpene is called squalene. So let me draw that in. Okay, just wanted to make sure that I actually got 30 carbon molecules in there, and I think I did, and that is squalene. It was important for me to get to squalene because this is the molecule that forms the base of all of the steroid hormones that our body makes.